Hello, everyone. Thank you for joining our this month's meeting. This is the first meeting of 2022, and I hope that you would enjoy it like our all other previous sessions. So today is all about ASHRAE 209, the standard for energy simulation as a design tool. We have three amazing speakers today. Eddy Santosa, Dr. Dru Crawley, and Chris Schaffner. So each of them gonna talk briefly about what is happening in the ASHRAE 209. They are all members from ASHRAE 209 committee. So they will represent an overview of the standard as it exists and highlight some of the changes under discussion. Also, there's a chance for you to provide feedback, share your ideas and suggestions. And ask any question you have. So you can put questions in the chat and then we can address it to the presenters. I think after the each presenter, the presentation of each presenter. So I leave the introduction of the presenters to themselves so they can introduce themselves and then go on with the presentation. Thank you so much for joining us again. And Eddy, floor is yours. Thank you.
Yeah, I would like to introduce myself. My name is Eddy Santosa. I'm based in sunny California, Los Angeles, in Pasadena. I'm a senior building performance with IMEC. I've been working in building performance since maybe 2005, and I'm currently also serve as a IBPSA board director and also the member of the 209.
Introduce myself. I'm Dru Crawley. I'm a Bentley Fellow and Director of Building Performance Research at Bentley. I'm a member of the 209 committee, very active in ASHRAE and IBPSA. I'm the past president of IBPSA USA and currently the Vice President of the International Association.
Thank you, Dru, and I'm Chris Schaffner. I'm the CEO and founder of the Green Engineer, based here in the Boston area in Concord, Mass. I'm a mechanical engineer by training and a member of the ASHRAE 209 committee. I'm also newly reappointed to the USGBC Energy and Atmosphere Technical Advisory Group, and I'm a consultant to the ASHRAE 90.1 committee as well. So involved in a lot of things related to standards and green buildings and such. I want to thank everybody for coming, and another hopefully successful IBPSA Boston chapter event. We've really done I think a great job on these in the last couple of years since the pandemic started, and being able to bring so many people together on Zoom. And I'm seeing here we've got over 40 people online, and I know we had more than 100 signed up, and people from all around the world. So that's tremendous. What we're going to talk tonight is about ASHRAE 209. And for those of you who are not familiar with it, we'll get an overview of that. And for those of you who are familiar with it, we're going to give you a chance to give us some input and some feedback. As was mentioned, all three of us are members of the ASHRAE 209 committee. And so there's an active effort going on to potentially update that standard, and we're looking for input from users to help us understand how we can make a better adoption. So we're going to start with what is it, and specifically why it exists, and then what is it, and then I'll go through some of the details of the different cycles of modeling, and then we'll talk a bit about the future of the standard. So with that, I'm going to hand over to Eddy, and he's going to walk us through the first section here on the standard itself.
Eddy, I believe you're on mute.
Yeah, you are muted, Eddy.
Okay, I apologize. Thank you, Chris. How we got here, I think energy model has been used since pre-1980s and primarily used for research and design, and also the cost of computational is very expensive and it's very uncommon. starting in the 1980s, energy models start coming to the construction industry, primarily used for Title 24 performance-based code and ASHRAE 90.1. And we also know that the desktop computer become more common in those era. And 1987, IBPSA has been established to help the enhance the building performance in the market. I think the energy modeling become very popular, starting the adaptation of LEED, especially starting, I think, with around 2007, 2010, it become very popular. I started in my career around that era. I think I still remember when 2007, I was in a job interview, and I put in my resume, basically I have energy modeling skill, and architects still ask, is it like 3D Max? So apparently, although it's become popular, it's not very common being used. But hopefully now I believe now everybody know what is energy modeling. And 90.1 primarily used as a tool to verification on the LEED, and everybody become familiar with the process. And in 2018, ASHRAE start introducing 209, which is primarily describe the methodology to use energy modeling during the design process, which is one step further before from the use of the energy modeling as a validation tool, and now become focusing about the methodology in the design. So why we use energy modeling? As you can see, if we do a lot of modeling in early, we can influence impact very significantly in the project than if you do the modeling in the end of the process. And the level of effort also slightly different. In the end, you have more complex stuff, but yeah, it's hard to change because everything already decided. And if any change that you do will affect all the drawing and everything. So it's a lot of effort itself to change any project in that level if you do energy modeling in the late of the stage. However, primarily, I think energy modeling still used in the end of the process. I'm working in a few companies and always ask people, how do you use energy modeling? They still use primarily during for load calculation and for the compliance process, although more and more people use it in the design process. So as I mentioned, it's a two primary use of energy modeling as a design tool and validation tool. I think validation tool, we knew about that, rebate certification, especially LEED, code compliance, whether you go to ASHRAE 90.1 Appendix G or energy cost budget or using ICC performance-based. And the design tool, we use energy modeling of building performance modeling for define a benchmarking or define a project energy goal, as well as test different options in the design. So that's the one that we discuss in 209 primarily. So the next of the use of 209 was also influenced by the popularity of the integrative process design. If you talk with architects or the design process, the integrative process become more and more popular, I think, because you can define the project goal and the process in early, and after that you can have a more smooth process than comparing you work in a separate way, and after that you try to combine on to refine it in the end. So it's become a popular process, and it's like a lean project management or integrated process is become very common being used to define the building. That's maybe we can talk about different type of building component like habitat, water, energy, material, and budget very early. I think it's very critical in here to use the integrative process design in the construction project currently. In terms of the motivation, why we use early energy model, especially in the conceptual design, as we mentioned, the potential benefit is higher than if you do it in a schematic design or in the subsequent process. And the simulation costs also have a different, although maybe if you do a lot of early design, your early design will be higher, but I think that's the one that potential benefit that align with the benefit, align with along with the process of design. So higher and getting lower. I talked with the architect actually what is actually the benefit we use early design. And for him, it's actually really helpful while we do early design energy model and define all the envelope requirement, they will have a smoother process during DD and SCD. So have less revision, has a better implementation in Rapid. So he predict maybe he can save time about 5 to 10%. So it's very significant in terms of like talking about the overall design process. So why do we need the 209? I think we know that 90.1 is very popular as a validation process and for code compliance checking, but 209 is very critical. There is a few things that we see is first is to optimize the building. I think it's the validation process. That's a very good also for organization to define when they certify high performance building. So to define the methodology and requirement, or when you give an incentive to the project team to do the early design process. There's a few incentive programs that give you specifically in early design process. For example, like Austin Energy, I believe they still give incentive program if you do early design. So it can help a utility company to define the requirement. Client and architect, that's very critical. I think that I believe it should be the primarily used to 209 because using a 209 in your RFP, basically you can have a similar proposal between two companies, right? If I ask, hey, I want an early design from your company, two companies will give me a different thing. So by defining the RFP based on a 209, the architect or the client can make a comparison apple to apple. So the other use of the 209 that's very important is the primarily is with the AIA 2030 challenge. I don't know whether many of you know 2030. If you're not familiar, it's basically a challenge that's being put by AIA to push the carbon neutral in 2030. So based on the report that they do, actually, they make a comparison between model and non-model building. And there is a significant impact or saving if you do energy model in building just do a compliance in the end of the process. So I believe the number is 10% to 20% reduction. You can see the report. I think each year they make a comparison between two, but the number is pretty consistent across the year. The difference between non-model and model building is about 10 to 20%. And I was involved a lot in the 2030 as well. I think that number is pretty consistent with my own number as well. Another potential use of a 209 is lead integrative process credit, although now being updated in 4.1. But basically in a lead version 0.4, you need to do 2 analysis in each of the category that it was mentioned. I believe in a version 4.1, they're more flexible. They use, I think, as applicable, then you need to do one by one. But it's also giving you, the 209 can give you a framework how you use with to achieve the lead integrative process design, which the goal is actually to establish the benchmarking of the project, the source EUI, or do a load reduction, which is Dru will explain. I think it's all under cycle 3, and the reduction in potential energy saving, and also influence the decision making in the subsequent design process. I think that's very critical. Although in the earlier adaptation, I think I met a few lead consultants that, oh, can you just fill up the form only? So although we don't do an energy model, but they want to get early design and integrative process credit, they insist the project team to just fill up the form, which is, I think, is not good practice. So I think the next I will handing out to the Dru that will explain the detail of the structure of 209. Dru, go ahead.
Great. Thanks, Eddy. So I'm going to talk about structure, and it will kind of repeat ourselves several because Chris is going to follow up with modeling cycles, which is one of the pieces of this. But Eddie's given you a great overview of why we need this standard, and particularly the uniformity for owners and architects to understand what it is that they're trying to get as far as simulation. And so standard 209, actually, I want to back up once. I can't. No, it's moving forward. Sorry. Yeah, there you go. So standard 209 is really starting out to be the minimum requirements for how you're doing energy simulation, particularly around design. It's supposed to be adopted by organizations that are certifying the buildings, but also utilities and agencies. So they have a common way of really specifying that. Structure looks an awful lot like a lot of ASHRAE standards. It has a forward, a purpose, scope, definitions, how it's to be used, and then the meat of the section is really in sections 5 through 9, which includes some normative appendices for that. So section 5 has a series of general requirements. You must do all of these items. And then there are some general modeling cycle requirements. We'll go into each of these a little bit more. Sorry. So there are minimum requirements for the software you use. What are its capabilities? How are you supposed to do? Who is qualified to do this in particular ways? Analysis of the site and climate to be able to provide some background information to understand what the issues and the challenges are going to be for that site. How we're going to benchmark the building, how it's going to be seen as a or is processed. How are we going to make sure that we're getting there? How you set up and do an energy charrette, and finally is establishing goals for the particular project. Now they may be related to getting lead points or 2030 challenge or whatever you're doing, but it's one of those things where you sit down as a team. Within the general modeling cycle requirements, there are requirements about setting baselines and goals, what data you need to be able to work with there, how you report that out, and how you make sure that you've got decent results quality-wise for that. As far as structure of the main core, the design modeling cycles, and Chris will go over each of these in more detail, but you have a simple box conceptual, load reduction, a lot of focus on load reduction, HVAC system selection, design refinement, design integration optimization, and energy simulation aided value engineering. So focus there first. So timing wise, we're looking at the first two for conceptual. Schematic, we think about loads and HVAC and design development, refinement and optimization, and then finally where we are preparing final documents. So here's an example of the simple box modeling text. So we have a purpose, where it's applicable, and then how you go about doing it. There often is additional information in the some of the appendices, whether they're normative or informative. So if we look again at the structure, general requirements, we talked about most of these already. Section 6, the design modeling cycles, and then there are also construction and operations modeling cycles as designed, change orders as built, and comparing design to actual. So how do you comply? Well, first, it's not mandatory for all buildings. There are some standards. 189.1 has recently brought 189 in, particularly some of the elements of that. But you have to establish an energy performance goal first. You have to do an energy charrette. You have to do a climate. It needs to be somebody who's certified in the area, either BEMP or BESA, to either perform or supervise the modeling. You have to do an energy model before the end of schematic, focused on reducing peak loads. That's the model 3, cycle 3, and then provide at least one other design phase model, none of which is the design. So if we look at it, it's climate benchmarking, energy charrette, energy performance goals, general modeling cycle requirements, and section the modeling cycle 3 plus one additional design phase modeling cycle. So you don't have to do everything here, but we give you kind of an overview of what options are there. So here shows you what you can do, either all the requirements in 5.7 and any one of these other 6 options, because 3 is already required. This is optional, and this is if the adopting authority decides they want to add additional things after the project is complete, or as designed, change order built, and energy performance comparison also there, but they are not part of the basic sets of it. So if we look at some of the general requirements, looking at climate and site analysis, making sure that the design team knows where the challenges are, and to begin to start listing climate and site specific design strategies. What will work here? What are the opportunities for dealing with the climate in early design? Similarly, sections 5.4 to 5.6 deal with benchmarking, charrette, and performance, starting off with benchmarking databases such as CBEX or Energy Star Target Finder, AIA 2030, or DOE Building Performance Database as well. Charrette, it describes what needs to be done. There are good examples of lots of different opportunities out there, but trying to help the team understand, and it's not just the energy modeling doing that, this is the entire design team working in this. But why are we doing energy modeling? What metrics are we going to set as a team? Results of anything that have been done before. Maybe there have been some climate analysis. How are we going to decide what a good solution is financially? And then where are we going next, and who's going to do what? And those are all very important topics for that. So setting the goals, this is the overall building energy goal. It could be at a specific discipline or system specific, looking at envelope, daylighting, plugs process, hot water, HVAC. And those may be, we're trying to go beyond another standard. This is actually a piece of one of the advanced energy design guides showing a possibility of where that could go if you're trying to get beyond code, for example, and that may be one approach for doing that. You could set, we want to exceed the requirements in the envelope section or the lighting section is a way to move forward. Typical modeling cycle, starting kind of top center, updating the baseline goals to make sure that we still make sense. And this is for each of the cycles. Gathering input data, project specific incremental costs, making sure that we've got the data we need, and then conducting the analysis and the results and making sure it's clear to the team what it is and how it reflects that. So you do most of these things each cycle. And who does what? For starting down kind of the list of where we're going, we've got designers and owners on the left and analysts on the right. The analysts are going to be doing the climate and site analysis and the benchmarking, gathering that data about our site, the climate, and what are reasonable goals or where we're starting. And then charrette is where everybody's meeting. Designers and owners are really responsible for setting those goals and being able, but also to make sure that everybody understands what's needed in terms of inputs and baselines and what we're trying to achieve here. The analysts then will do their analysis, which of the modeling cycles report what they use as data for running the model and also the results. And so back and forth with that to make sure that the analysts and the design owner team really understand what it is and how that's worked. So if they have questions, they can be resolved quickly. So that iterates as we go through the cycle, being able to change at each section or each design phase. So at this point, I'll hand it on to Chris and let him talk about the modeling cycles.
Yeah, thanks, Dru, and thanks, Eddy. So, again, I mean, I think the thing about 209 that's interesting to me is that part of what we're trying to do is create a common understanding of the scope of work that we do for building simulation on a project. And certainly as a modeler, and I know other people on the Zoom tonight have had this experience where a client is asking us for some modeling effort, and we'll propose one thing, and another firm will propose something very different, with different scope, different prices and such. And so by tying things down to 209, it gives us an opportunity to have an apples to apples comparison. If one firm is only doing modeling based on the final as designed building, and another firm is offering to do conceptual modeling and load reduction modeling, there's a very different set of services and a very different set of outcomes that are come out of that. So I think that's the real power that 209 potentially has. So what I'm going to do is walk through very briefly each of these cycles and explain what's involved in this. We do have question and answer happening in the chat. If you've got any questions for us, go ahead and type that in there. And then we're going to be looking for your feedback shortly on this as well. So let's dive into the design phase modeling cycles first. Let's see if I can make this thing move again. So first one is simple box modeling. So here we're creating a prototype model or a simple model based on the overall size of the building, its location, its program. And then we can do things like varying the building geometry, the window wall ratio, and the orientation of the building to understand how that might impact the design. Thermal performance of the envelope is another piece. So you might be doing this at concept design, even before you've picked the site, and certainly before you've created the building form, to see what opportunities there are to affect the energy performance. Cycle 2 is going a little deeper on that, and you're looking the internal loads and HVAC systems constant, but then looking specifically at different building options as far as the form and architecture. Modeling cycle 3, the load reduction modeling. This is the key one. This is the one that's required in the basic compliance path. And the idea is that we're doing this during schematic design or earlier, and we are trying to identify how to reduce the loads. If we think about designing an efficient building, too often we jump to the idea of let's do efficient equipment, right? So we'll put an efficient chiller in, and that'll save us energy. But if we can first figure out how to make that chiller smaller, if we can reduce the loads, then we can do that in a more cost-effective way. And so this load reduction cycle is a critical step here. And so we're trying to identify what are the strategies that have the largest impact, and looking at a number of different strategies as part of that. Modeling cycle 4 is about HVAC system selection. So after you've done the load reduction, then we can compare different alternative HVAC systems. So we're keeping other things constant and just varying the HVAC system type. Modeling cycle 5 would be design refinement. So this is happening potentially later. This is maybe in design development, but before the end of CDs. And here we are looking at additional design refinement. If we're first of all looking at the building form and orientation, minimizing the loads, picking the HVAC system, now we're refining further. So maybe we've got a system type, but we're looking at things like the individual pieces of equipment and their performance, or control strategies, lighting design, things like that could be part of that. And you could also look at certainly service water heating, plug-in process loads, or anything else. Integration and optimization. So here we're trying to optimize this design. We're narrowing in, and this is again something we're doing probably in CDs at this point. So it's a cycle that is looking at a narrower set of alternatives, and we're optimizing. And then value engineering. This is an important step that a lot of projects fail to do. We design around something, and then the pricing comes in, and it's too expensive, and we say, what do we cut? Well, let's cut some of this efficiency we've got here. We don't go back and see what happens to the building performance. We don't see if there's actually maybe short-sighted, a life cycle benefit. So with the value engineering step, the modeling cycle, we're going to be modeling the VE options to see what kind of impact they're going to have on building energy performance, and then tying that to life cycle costs. So now we've completed design and we move into the construction and operations phase modeling cycles. And again, just to repeat what Dru said, in a typical process, you wouldn't necessarily be doing all of these cycles. You would identify the cycles that were appropriate for your project. So the as designed energy performance, this is the final design. This is typically the only step that some projects do. This is what you're going to use for code compliance or submitting to LEED or some other green building standard. So you're going to be the as designed project here, you know, with the 100% design drawings, 100% CDs, and then contemplated change orders. So you have a VE process before you've completed design, but it's also possible that during the construction process, you may come back with proposed substitutions coming from the building team, the construction team. And so again, we should be looking at that with the model. And then modeling cycle 10 is as-built energy performance. So here we take that as designed, but we'd adjust it based on any changes that happened during construction. So if there was a substitution or we know that something was done differently, we'd capture that here. And then finally, there's the post-occupancy energy comparison. So this is the M&V process. This is the idea of the calibrated model. And so, you know, the idea here is that the model can live on and provide some value to the owner beyond just the design process, because we can now use this model once it's calibrated to look at future energy improvements to the building. And it's also can be used for, you know, understanding how much did we really save, right? And there's some specific requirements around that. So that's the modeling cycles in a really quick summary. You get this nice little table here that Dru, you could explain who developed this originally and give them some credit, but this.
Yeah, this was, I did a presentation for ASHRAE Brazil and IBPSA Brazil probably about 1.5 years ago. And I talked about just the pieces we just talked about. And then Professor Hernandez Neto from University of Sao Paulo then had prepared this document, really showing the same thing we've been showing, but really trying to get it all on one page with some more text. And he went on to talk about how 209 is already being used within Brazil.
Yeah, so I think one of the things that, you know, the lesson learned from this is 209 came out in 2018. And I think, you know, like any standard, we certainly expect that, well, the whole world is waiting for this and they'll jump on this and start using it. And what we found is that the uptake of 209 wasn't perhaps quite as quick as we thought. I know that one disappointment was that LEED, instead of adopting 209 as the requirement for the integrative process credit or for the energy optimization credit, simply references 209 in their LEED reference guide. So it gives it as a resource versus a requirement. You know, so we've been asking ourselves as part of this committee, what changes do we need to make to this? Is it just a matter of time and education, or are there things missing from this or other information that we might need to get wider adoption of this standard? And so there's you know, like every other ASHRAE standard, there's a committee working on this, and we've identified a number of different things that we're going to be working on. And I'll give you a quick overview of that. And then we'll throw it open to others to see what kind of ideas and suggestions you might have. So ASHRAE 209, and sometime, you know, in the future, probably not 2021 because that was last year, but sometime in the future we'll have an updated version of ASHRAE 209, and we're looking at putting under continuous maintenance as a possibility as well. Which is just a sort of an ASHRAE technical thing that will allow it to be changed in a different way. So the kinds of things that we're working on in this group, I'll hit the highlights and then we'll chat a little bit more. The first thing is looking at creating sample report templates for the different modeling cycles. So a little more information about what is the deliverable for a given given modeling cycle? What does it look like? And we think that that might be helpful to modelers to make a more standard way to present information. And then the new modeling cycles that have been identified. So one thing that the standard doesn't do very well right now is really apply to existing buildings being retrofit or renovated in a major way. So we've got a lot around from the ground up new construction. And so we're looking at modeling cycles that would be more applicable to retrofits and renovations. Looking at a modeling cycle specifically on the facade and the enclosure. So instead of just looking at the massing and general envelope things, to be more specific about the envelope construction. Another topic that's come up frequently is the idea of modeling to a specific target. And we're seeing this a lot. I'm seeing this a lot in my work that various organizations and standards are saying design to this EUI, model to this EUI. So how do you do that? That's a tricky thing. So much of what we've done in modeling in the past has been comparing against the baseline and figuring out percent savings. So one target that's very popular, of course, is net zero. So net zero modeling. How do we use modeling as part of a net zero energy building? Another piece that is being contemplated is setting some ground rules for doing future climate analysis. So people often ask, well, what's it going to be like in 20 or 30 years with changing weather? How will the building perform at that point? Some guidelines around that. And then also modeling thermal comfort as one of the cycles that hasn't really been addressed in a significant way in the existing modeling cycles. So those are modeling cycles that folks are working on that we're looking to implement into 209. And I think the structure would be the same, that those would be optional modeling cycles, but give some rules about how those work. And really, the hope is that so the city of Boston, for example, has got their carbon neutral building assessment requirement. And so they're asking for a model that will show a specific EUI as part of the zoning process in concept design. And so an organization like the BPDA could potentially reference 209, say, follow 209 and do modeling and show us this result. Identify the specific parts of 209 that make that. A couple other things that are being contemplated to add to 209. QA/QC, a new section on QA/QC guidance. Now this gets a little tricky because we're a standard, not a user's guide, and so there are differences in how you write those sorts of things. But having some basic information about QA/QC, and then also some information and help on standard ways to compute carbon emissions and other metrics. There's certainly a lot of variety in how people might look at different energy metrics for their models. ASHRAE traditionally has used energy cost in things like 90.1, and we're seeing interest in the market for obviously carbon and other metrics for energy instead of energy costs. So how do those get incorporated as well? So that's what we're thinking about. Drew, anything else you want to add there?
Yeah, several standards are already really looking at the carbon emissions, and 90.1 and 189 actually have some carbon calculations, but this is a big topic within ASHRAE right now with our decarbonization task force, and how do we deal with carbon in a kind of a global way throughout all our standards. So yeah, I think IEQ was in here as well. I don't remember that. And also, I know there's thinking within, there was a question that just popped up about embodied carbon. And that is one of the things that is being considered in general, just to move forward on that. There's a long list of things that people are thinking about, though, but this is a great summary for it.
Yep. And Eddie, I want to give you a chance to other things that you're thinking about in 209 or that you've seen us talking about.
I think it's covered everything. I think maybe like an example of RFP, I think we talk about that also. So hopefully that's the contract language that some people talk about that potentially can be adopted as well to help the people I think, yeah, you already mentioned the sample report template. That's very useful.
Okay. So that work's all ongoing, and the timing of that is that we're trying to get that done sooner rather than later. I don't know that we have a specific deadline. If Jason were on here, he'd probably tell us what that deadline was. But there are some questions coming in, and before we start diving into questions, I wonder, I know that some other people from the 209 committee were planning to join tonight. Is anybody else from 209 committee here? Maybe raise your hand if you are. All right, I'm not seeing anybody raise their hand. If it's okay, I'll just read off a few of these questions and we can try to answer them. And we're interested in not, I think suggestions are great too. So give us feedback and give us ideas. But we've got a good one here from Mike Barker to start with. How does grid interaction and self-generation get factored into load reduction? There's a complex trade-off between efficiency and generation and the shaping of the load profile to reduce carbon. Would anybody like to take that one on?
Sure, I will. Yeah, that is a big issue. I know the decarbonization task force within ASHRAE has a whole working group of about 20 people looking at particularly the grid interaction issue. Dealing with the carbon, that if you look at states that are already definitely delving into that, California, for example, has time of use carbon factors. Right now, the 189.1 committee on is looking at carbon factors that are going to be 24-hour streams. There'll probably be one per month or one per season. We haven't quite settled on that. But yes, that is, Mike, you're right. That is a real challenge, balancing the two, because it changes the answer where you're going to, do you do efficiency first or do you do carbon? Because if you're doing carbon, you may be messing up the cost associated with it.
I think that's a good place for us to get some clarity and standardization, because what I do see now is people are often kind of shopping their carbon factors, right? So
yeah,
do I use my Energy Star number, or maybe I can find some different number that reflects my location, or maybe I'll find time of day information, and there's always the opportunity for gaming in any of our simulations, and that's a good place to do some gaming. So having some rules around that would be helpful.
189.1 has tried to deal with that by saying you have to be efficient and reduce carbon. You can't do one or the other. So it's not, we're not just throwing energy costs and energy efficiency out the window as we sort of carbon free.
So Justin asked a good question here. Does 209 have a role in normalizing assumptions for end uses like plug loads in offices or domestic hot water flow rates in residential? End uses that can represent a large share of total energy, but are often based on assumptions that can vary greatly between modelers, especially in early stage. Eddy or Dru, you want to take that on?
Maybe I will try. I think no. I think currently we don't have a plan on that one, although that's probably something that we can discuss. But I believe 209 is more about the process, and more we're going to predictive modeling. More and more, actually, we need to talk with the client and define the load itself. We cannot just rely on the standard anymore. While we keep moving closer and closer to net zero ready building or predictive modeling. And I think that's the one that in my thinking, but so far I don't hear any. I think it's not in the current 209.
Yeah, I mean, again, that goes to the issue of a standard versus a user's guide. And I'm reminded of, I believe it was a document, and it probably still exists, and I'm just ignorant, called ComNet, that was trying to create a standard set of assumptions that we would use in our models. And that, the idea was to somehow normalize things on this 100-point scale and and use standard assumptions. And the tricky part of that is, as Eddy mentions, is that are we trying to simulate reality, or are we just trying to do some sort of fair fair analysis, or are we trying to actually predict what's going to happen? So the more and more we have things like plug loads set by a standard, the less and less likely we are to be modeling reality, I think.
And I agree, but I think if you're starting to look at things where you're trying to reach a particular EUI, that you're going to wind up needing some sort of standardized set of those squishy inputs that you can game a little bit, because otherwise you're not going to be able to compare different projects fairly.
Yep. And then Mike Barker also says, why net zero energy rather focus on net zero carbon? So I think I misspoke. And when we say net zero, the net zero modeling can be energy or carbon. And the idea is simply about modeling to an absolute target. It's the thought that we need to create some guidelines on that. David asks or suggests that using 209 in performance contracting simulations on existing buildings. So that's an interesting approach. That basically would take that last cycle of 209, what cycle? What do we call that cycle? The post-occupancy energy performance cycle. And that would, that's certainly an option if somebody's doing that as part of their performance contracting contract. That would make sense to do that.
It also could lead, to a good starting point for the renovation piece, that if somebody's doing performance contracting, they can understand how to create the baseline and calibrate the model and all the various pieces you have to do there to start that piece. So I think some of the things we're doing are going to have support for that.
Yeah. So David also, in his second comment, says that for commissioning, he often requests to review any energy model and ask the modelers if they follow 209. And I guess I'll follow up and ask, do any of them say, yes, of course we do? And if so, how many? And then also suggests that referencing ASHRAE 209 and Standard 202 or Guideline 0, which are both standards around commissioning, could help adoption. And also referencing 209 in 90.1, which I think we're working on that one. I think we're going to get that one in there as a little preamble to the Appendix G.
I think that's underway, hopefully, for this 2022 version of 90.1.
Right. And then Henry asks or says, I use 209 for utility to deciding on approach, audit versus design studies, and structuring a project scope. Interested in participating in 209 development. Okay. Who else has got a question or a comment or suggestion for us? So you guys are all now ASHRAE 209 experts, and you're going to use it on your project starting tomorrow. And if not, what's the holdup? Why not? Anybody want to take yourself off mute and tell us?
This is Eric Studer. I bought a copy of this when it came out, and I looked over it, and I found it opaque and very hard to use and kind of jammed into as few pages as possible. And it's just not a very accessible thing. And it also makes energy modeling look far more complicated than it needs to be. So I think that it would be helpful if it was not necessarily shoehorned into the standard ASHRAE template. And if there were different packages, say, that somebody could choose between, instead of having to pick different things out of a list and say, here, we want you to do this, this, and this. It's easier if they just say, here, go do that.
So you're suggesting there would be a sort of a standard design construction package that might include 3 or 4 cycles that you would say this is what you should typically use.
It would make it a lot easier for people to say, this is what we want. We want this right here because we did it on the previous project and it worked great.
Yeah.
Yeah. Refer to one thing as opposed to, 6 different things.
Yeah, I definitely hear you on the opaque ASHRAE standard. I look at it too, and I, struggle with that. Dru or Eddy, any thoughts on that?
I think there is an effort to make a additional, maybe supplemental presentation or something after the end of the development to make it easier to digest. I think I agree that personally it's a bit overwhelming when you read the first time, but after you read, probably it's not as difficult as you think. But yeah, there are efforts that feedback that I think definitely we will maybe make like a promotional or like a brochure that easy, so you don't need to flip. Like this slide is actually easy to digest compared to standard, right? I think that it's already on our mind, and also make it simpler. I think that's the one. I think I agree. Sometimes we don't need like 100 report result when you only need a few, maybe table or something, or even one graphic.
Yeah, I think we have some work to do, but we need pieces like this that can help explain. But even this, I felt this was overwhelming, but I know the standard pretty well. So I think we have some opportunity here to start saying, okay, to start creating scenarios for various users of the standard, saying, I'm an architect and I need some simulation done. What should I consider? What packages should I put together? And those could be informative appendices toward the end of the document. So it makes it much easier to understand from, yeah, this is kind of a geeky, nerdy view of simulation, but I think it did get a long way toward really distilling a lot of the information, and we just need to repackage it a bit.
I think I saw Mariana had a question.
Yes, and I was muted. I was going to start. So, hey, I'm Mariana, and I think just to add on to a couple of thoughts there, I think from the modeler's perspective, a question that I encounter often is regarding quality assurance of models and how do you make sure that the results make sense. And every building is different, and so every model is different. And this is, I think, a very comprehensive list of inputs that are included in the appendix. And full disclosure, I personally have never used this before, this standard, but maybe I should, and I'll definitely read it a little bit more closely. And again, I think Chris said earlier, there's a distinction maybe between a standard and a guideline, but I wonder if there's an opportunity to go a little bit more in depth in terms of best practices for not just providing a list of, here are the things to check, but I don't know, going a little bit more in depth. I wonder if that would be more useful to people who are really, trying to ensure that the results of their models make sense. I don't know what you all think of that, or whether that might be outside the scope of the standard.
Well, I think that's a pretty common thing that we've heard. We've tried to talk to some other potential users to find out why they haven't been using it, and that was one of the pieces. It's a little opaque. And if we're trying to get a developer to put this in their RFP language, it's not in a format that a developer is used to looking at. And the suggestion has come up that we need some kind of a user's manual or something like that. That's a challenge to do that because of the way that ASHRAE committees and ASHRAE standards work. So it's possible that we can't do that in a simple way, but I think where we're trying to do that is to add a number of informative appendices that will help with that to some degree.
I think that the other thought is that and also I'm coming at this maybe from a bit of an ignorant perspective of how the different ASHRAE standards are typically linked to each other, but people refer, I guess in practice, they refer so often to 90.1. And so I guess, I don't know, is there just a map that's just like a reference, like, okay, if you're doing anything with 90.1, you should probably also look at 209 to make sure you're following these, or if, I don't know, if that would be beneficial.
Yeah, it's a good comment. Eddy or Dru, any thoughts, any of that?
I think that's all pretty critical to what we're doing, and you're right, we don't cover that yet, but that was in the list of things that are people interested and working groups are working on now.
Yep. I think we're running up against the clock here. We're about out of time, but we've got time for maybe one or two more if anybody's got another question or a comment. I see a couple more that have come into the chat. Mike adds that project managers need to be aware of ASHRAE 209 so that the early design meetings can have structure. And David mentions that it's hard to get architects, design teams, and owners to really trust energy modeling in the conceptual phase. And after the first go around, the design and construction team tend to ignore the modeling, particularly when first costs start to drive design decisions. I think those are all very valid comments.
Yeah,
Well, go ahead, Eddy.
I just want to add about David's comment on that one. I think I spent my career mostly in an architecture firm. I think it's how one thing is as an energy modeler is to do energy modeling. Second is to sell your product. So how you influence people is very important to understand each client perspective and architect perspective, so they can trust you. And there's not just they don't see you as a people who just push energy, but they're concerned about their goal also. So that's my suggestion. I think it takes a while to be able to do that, but that's, I think, my suggestion. You need to take a look from another perspective of owner or architect, what they're concerned about as a result of energy modeling. So you need to selling on that perspective sometimes.
I'm reminded of a presentation that our friend Craig Simmons and some others gave at a recent IBPSA conference about how to put energy modeling, how to present the results to architects and designers. So I think that's really part of what we need to figure out as an industry. And maybe 209 is not the place for that, but we need to be better at translating the results of our models into information that our clients can actually use. And we're often not very good at that. I personally can view the whole world through a series of spreadsheets, and I get that the rest of the world doesn't view things that way. Dru, do you have any last words before we wrap up?
I don't, except to watch pronouncements of public review drafts and other things. I know that the Standard 209 is considering having IBPSA being a co-sponsor of this particular standard. So look for more information about that coming soon.
Yeah, that's an important point. IBPSA is very involved in the development of this standard. Eddy, any last thoughts?
Yeah, I think it's a last thought. If any feedback or something that you don't want to mention it now or don't have a time, feel free to email us. I think that's important feedback. Whether you use it or you don't use it, why you don't use it, why you use it, or that's a thing. I think that's critical. So we can understand and try to implement. And hopefully in the future, once a new standard coming, more and more people adopt it and use it.
Right. Yeah, Eddy, that's great, and I would second that. If you've got any feedback or specific comments, you can feel free to email me. You can see all about contact there. Reach out to us with anything here. I just, as a closing thought, the climate crisis, it gets worse. It's more critical all the time. We've been working on these problems for a long time. I've been doing energy simulation since the 1990s, and it's never been more. First of all, more in demand. But also more critical to our world, and yet so much time and effort seems to be not put in the best direction that really gets to the best results. And so I think, the efforts of things like 209 are a way to try to focus our efforts so that we are getting what we need in this, for our planet ultimately. So I think it's important that we get this right and that we all work together to help solve these problems. And I know that you all are working very hard on this as well. So I appreciate that. And thank you for your attendance tonight. And I'll head it back to Shide and the gang. If you got any other last things for IBPSA Boston, what are we doing next month?
Thank you so much. First of all, I wanted to thank you, our presenters, for their amazing and very interesting presentation. And thank you for all the participants for tuning in. Next month would be the Harvard Graduate School of Design project presentation. So they're gonna, a couple of the students would come and talk about their projects. And we have much more interesting meetings coming up for this year. So I hope that we would see all of you again. And thank you again for participating.
Night, everybody.
Thank you. Bye-bye.
Bye, everybody.
Thank you all.